Hello, and welcome to the Undet Toolbox version 2 features video series. In this video I will present meshing functionality. Meshing is often a must-to-have feature when dealing with point clouds. We experienced it many times by ourselves. In such tasks like ground surface extraction, 3D modeling of irregular shape objects, or visualization and analysis of complicated surfaces, meshing is a need. For this purpose we created a comprehensive meshing functionality that is applicable in many different ways. Meshing ground surfaces. Undet meshing algorithm will very precisely select only ground surface and eliminate trashes and other objects such like vegetation, houses, cars, pedestrians, etc. Mesh editing tools will allow you to join several different meshes, close holes, remove long edges and spikes. Additionally, there is a mesh sectioning possibility for roadways or surface profiling. And the toolbox mesh also works great for meshing irregular objects or heritage objects such like ruins. Our mesh also has texturing possibility for better interpretation of 3D surfaces. I am in AutoCAD environment right now, and I have a mobile mapping project over here, two runs, one and the other one. You see the 2D black and white mode. Let's turn on the 3D color mode over here. And this is how the general situation looks like. And as you see, there is a pretty huge decimation level. You see 1 point in 1 meter, and this is because of the project type, which is topography. So let's go into details and let's create a view section. Just before, I will align my view by line like this, and let's cut a piece of point cloud somewhere here. Let's check the distance. So it is something like 350 meters, and as you see now, the point cloud is much denser. The indicator is green. It means that we see all scan points. And you may notice some cars on the road, electrical power lines, trees, a pedestrian path over here, houses. And let's create a mesh and extract the road surface and the surrounding territory surface. For this reason, we have dedicated place in the ribbon menu, and we basically have two options: regular mesh and directional mesh. So the difference is that if you can clearly define where the mesh should go, then you use directional mesh, but if not, the regular mesh is okay. So in this case, I will use directional mesh, and the first thing that you will be asked in the command line is to set first direction point. So basically you need to approximately show the vector with line like this, and then to select grid size of the mesh. So 1 or 2 meter would be definitely enough for topography, but I'll choose half meter just to have a dense and nice point cloud mesh. And then you need to click somewhere and define the base point, and your base point should be not somewhere on the top of the car or on the tree, but somewhere closer to the ground. So let's say in this case I'll select somewhere in more flat place on the ground surface, and the polygon appeared asking us to define mesh size. So let's say if I would like to mesh only half of this view section, I would reduce the polygon regions, but let's mesh entire view section and simply press enter now, and the mesh is going to be calculated. It will take a couple seconds. But it is fast and my mesh is already calculated. Okay, let's turn off the point cloud for a moment. And let's visualize mesh as a shaded object. And as you see, no trees, no cars, no houses, nothing, only perfectly extracted ground surface. Let's turn on the point cloud to visualize both of them at the same time. As you see, so no additional objects were taken into this mesh triangulation, only ground surface, and that's nicely done. Okay, let's say you want to edit this mesh. There is also some possibilities for mesh modification. So we can close holes, remove long edges, remove spikes, join two meshes. So let's see, I'll choose remove long edges, and let's choose it again. And you need to approximately just define the region with the polygon like this. Press enter and press enter once again, and a mesh cleanup dialog box will appear over here. You can define the length of your long edges, you can view them. Yep. They're over here. Press escape, and then again the mesh cleanup will appear, and you can increase the length or decrease of the long edges. And let's say I want to delete only these ones, and press delete. You will have your mesh cleaned from the long edges. You can also remove spikes. Let's say I'll choose now remove spikes. There are no spikes almost at all, because the mesh was generated perfectly. So let's pretend we have some spikes over here. I'll press enter once again, and the spikes will be removed automatically. Alright. Let's say you want to create a mesh section, and to see the profile of the road, you can do it instantly by clicking on this mesh section icon. You need to select mesh and then simply draw a line. So the mesh section is generated, and you see how it looks like. You can click on the mesh and hide objects. Or end objects isolation. Alright, let's delete now everything, and let's create another mesh. In a different way. Let's create another view section as well, so I will deactivate this one. And I want to create a mesh over here on that turn, so I will align my view once again, and I'll cut this region of the road with this turn together. And this situation is pretty similar, the same road and the surrounding objects. And in this case, let's say that I want to create only the road mesh, and I do not want to mesh any of the other surroundings, so I do not need to mesh any of the sideways and so on. So I'll simply select polyline over here, and I will define my regions with the polyline. I'll do it here very approximately, just for demonstration purpose. So let's say like this. Say over here, and in the other side like this. let's turn off the point cloud and turn on the snapping like that. So see, I have my approximate region. Yeah, really approximate, but let's pretend it's okay. Let's turn on the point cloud and let's create mesh one more time, but this time only of the road. Again, I'll choose directional mesh, very approximately I'll show the direction, and I'll choose grid size, let's say 0.5 meter, okay. But this time I'll select polyline from drawing, so I'll need to select this option, and let's select the polyline, and once again I need to select a base point somewhere inside the territory of this polyline. So I'll click on the road again, and now my surface mesh is going to be generated only within the area of this polyline. Calculations are done. Let's turn off the point cloud for a moment, and you see that my road was meshed. Only the territory inside the defined polygon with the polyline. Alright, let's delete the polyline. Let's hide mesh for a moment. And now let's say that I want to create multiple sections of this mesh. I want to create multiple sections of the road. You could use this mesh in Civil 3D as a native civil object, as a civil surface, if you would explode it into faces. So then Civil 3D will recognize it as a native civil object. But if you do not have Civil 3D, you can create multiple sections of the road over here as well. And let's say that I'm going to create sections in this way. So I will use polyline. I will draw it exactly in the center of the road, so exactly on the alignment. Again, I'll do it very approximately, just like that. I'll turn off the point cloud for a second, and I'll draw a perpendicular line to this alignment. Let's see. Something like 4 meters would be alright. Let's lengthen it 4 meters into the other side, and let's array it around the path of this polyline. Yep. So now I will turn on the point cloud, see how this looks together with the point cloud. Let's turn it off, and let's end our mesh isolation. So now I'm going to define my sections with this array, and it is very simple. You click on the mesh section over here in the ribbon menu, select the mesh, and then you have an option select in drawing. So you choose this option, and you can select lines or array. So I will select my array, click enter, and it will take a couple of seconds again to calculate sections. Right, so my yep, and this was my mistake, and I'll probably leave this mistake on purpose. So these multiple mesh sections were generated incorrectly because it directly depends on the view. So my view was something like this when I was generating these sections, and those lines that passed by the mesh generated small sections over here, as you see. And if you would like to properly generate multiple sections, you should have your view from the top, so that these lines or array would cross the section perpendicularly. So I'll generate the sections one more time. Let's choose sections, let's select the mesh, and let's select in drawing array. Press enter. And this time, as you see, my multiple mesh sections were generated properly. Okay, so this is what I wanted to show you regarding this mobile mapping point cloud project. Ground surface extraction, point cloud mesh editing, and section generation. I have now opened another point cloud project, an abutment, ruins of abutment of an old train bridge. This is considered to be a heritage object, and I'll show you how to proceed mesh over here. I have already created a view section. I see all points in this view section that were scanned, and I'll make this view section smaller just to see half of the object. And let's create the mesh of this abutment. In this case, I will use regular mesh option, and I'll click somewhere on the surface just before I need to define the grid size of the mesh, and I'll define it to 5 centimeters. And here is my polygon. I will increase it to mesh entire structure, but you have to be aware that this mesh works, let's say, up to 90 degrees. So it means that if the surface is turning more than 90, the mesh is stopping. So it will stop automatically where it reached close to 90 degrees. I'll press enter now. Again, a couple seconds for mesh calculations. And here is my mesh generated, and as you see, it stopped somewhere here. I'll turn off the point cloud, and I'll make the view shaded to visualize better the mesh. This is how it looks like. Again, a very dense and a very nicely done mesh. Let's say you would like to put on a texture. So if you would have some pictures, you could put on some pictures. I don't have, so I will create a picture. I will hide this mesh for a moment. I will hide the point cloud, and I will generate an orthophoto. So we have orthophoto generation over here, and there are 3 options: actual, projected, and custom. So the actual means that the orthophoto is going to have real dimensions. So let's say if I'm going to now create orthophoto of the surface, see that the surface is leaning a little bit to the right. So it means that the actual orthophoto is going to be leaning to the right as well, and it will be placed in a statistically calculated plane. Afterwards, I will select on this plane, somewhere on the surface of this plane. Projected means that the orthophoto is going to be straight even though the plane is leaning, and all the values are going to be projected to the orthophoto. So it will look like nice as well, but it will not have real dimensions, and the photo is going to be placed in this middle, in the mass center of the statistically calculated plane. And the ortho custom, it is the same as ortho projected, only you can define your place of the photo by line like this. So I'll choose now ortho actual, and I'll click somewhere on the surface. As you see, it automatically suggests me the polygon, and this size of the polygon is not some sort of random region. The plane was statistically calculated, and the algorithm thinks that over here the plane should stop, and over here the plane should stop, because here you see there is already a fillet edge. Over here there is a different plane, and I'll show you later on from another point of view why the algorithm stopped and suggested me only this size of the polygon. But I'll skip this. I will increase the polygon just for the moment, because I need to have a nice picture of entire view, and press enter. In this image preview, you can check out how your image will look like, and you can increase over here your pixel size if you want. Let's see, if you have not very densely scanned objects, we can increase pixel size to avoid some spaces between the points of the point cloud. I'll press OK, and I'll press OK one more time. So here is my orthophoto generated, and you see it is actual. It is leading as well. It goes through the statistically calculated plane, and as I mentioned, my statistically calculated plane was within this region over here and somewhere over here, but I increased my region of the polygon because I wanted to have entire picture. But the algorithm stopped suggesting me exactly that size of the polygon, because it recognized that this is already another plane, as you see, and this is the third plane, and over here this is already fillet edge. So this is a smart algorithm saying me that you should create several orthophotos probably if you would like to have actual dimensions in everyone, but I'll use this only for texturing, so it is fair enough. And I now will turn off the point cloud and unhide my mesh. And here we have texture feature and the icon of it. Click on it, select the mesh, and then you need to select the image, and you need to select image on its border over here. And here it is, the textured mesh. I will delete the image. This is how it looks like. Again, pretty nice. This is what I wanted to show you regarding Undet toolbox meshing functionality in this video tutorial, and thanks for watching it.